students, in the second exercise of polynomial, you will be dealing with what is the degree of the polynomial. If a degree of a polynomial is 2, then what is the mean in a polynomial? What is the meaning of degree of a polynomial? And what are you going to do with that? That we are going to learn in the second exercise. The first sum, find the value of the polynomial 5x minus 4x square plus 3. Okay. In that, okay, value of a polynomial. First you have to understand what is called a value of a polynomial. Here they are given the polynomial is 5x minus 4x square plus 3. Okay. This is the first sum. Okay. First sum. In this, I usually represent any polynomial in this format. P of x is equal to, P of x is equal to, and we write down the polynomial. Then they have given in your first part of the first question, they have given x is equal to 0. X is equal to 0. What does it mean? Suppose I am going to use the value of 0 in the place of x. What is going to be the value of the polynomial? That is the question. So I will express it as P of 0. In the place of x, I am going to use 0. So I write it as P of 0 is equal to 5 into 0 minus 4 into 0 square plus 3. And so the value becomes 3. All these both the terms, anything multiplied with 0 is 0. So these both the terms become 0, and so this value alone, constant term, doesn't change. So I write only that constant term and it's equal to 3. The second part of it, when the value of x is equal to minus 1. So P of minus 1, polynomial, how does the polynomial change when the value of x is going to be minus 1? 5 into minus 1 minus 4 into minus 1 whole square plus 3. Okay. Now this 5 into minus 1 becomes minus 5 and minus 1 square becomes minus 1 into minus 1 is plus 1. So 1 into 4. 4, but here already there is a minus. So it becomes minus 4 plus 3. Minus 5 minus 4. We have to add the numbers 5 and 4 and put the minus symbol there. So minus 5 minus 4 adds up to minus 9 plus 3, and again I have to subtract. There is both the symbols are different. So I have to subtract both the numbers and put the higher numbers symbol. So it becomes minus 6. This is the value of the polynomial when x is equal to minus 1 for this polynomial. Okay. Then the third sum is when x is equal to 2. When x is equal to 2, then a polynomial, when I substitute it with the value 2, it becomes 5 into 2 minus 4 into 2 square plus 3. Okay. So 5 2s are 10 and here again 2 2s are 4. 4 into 4 is minus 16 because already there is a minus. So it becomes minus 16 and plus 3. So it sums up 10 and 3, I add it up together, it becomes 13. 13, the plus 13 and minus 16. So as both the symbols are different, I have to subtract and put the higher numbers symbol, and so it comes to minus 3. Okay. Here it's a very direct question. They are given different polynomials and they asked you to substitute values 0, 1 and 2 for each polynomial. Okay. They are given 4 polynomials. You have to substitute values 0, 1 and 2. So I write the first polynomial. Second question, first part, P of y is equal to y square minus y plus 1. In that I have to substitute P of 0, P of 1 and P of 2. I have to find the values like that. P of 0 is equal to 0 square minus 0 plus 1 and it's equal to 1. Both the zeros, no value, only the constant doesn't change, so it's plus 1. Then P of 1 and 2. Okay. P of 1. So 1 square minus 1 and plus 1. 1 square value doesn't change. It's 1 minus 1 plus 1. And the 1 plus value and plus value I add 2 minus 1 and it's equal to 1 again. Okay. Then the P of 2. 2 square minus 2 1. 2 2s are 4 minus 2 plus 1. These both are plus numbers 4 and 1. So they add up as 5. 5 minus 2 is equal to 3. Okay. With this, these are the values of the first sum. Then the second sum, it's a second different polynomial. P of t is equal to 2 plus t plus 2t square minus t cube. Okay. Yeah. Then here again I have to substitute the different values for t. In the place of t I am going to use 0, 1 and 2. P of 0 is equal to P of 0 is equal to 2 plus, in the place of t, 0 plus 2 into 0 square minus 0 cube. Okay. All these values become 0, only the 2 remains, and so the constant 2 alone has got value there. Then P of 1. Okay. 2 plus 1 plus 2 into 1 square minus 1 cube, and then that adds to 2 plus 1 plus 2 to 1 is 1, 1 into 2 is 2 minus 1. Again there are 3 positive numbers and 1 negative number. I add up all these positive numbers. 2 plus 1, 3, 4, 5. 5 minus 1 is equal to 4. Okay. Then P of 2 we have to find. In the place of t I am going to substitute 2 there. 2 plus 2 into 2 square minus 2 cube. Here 2 plus 2 plus 2 2s are 4, and again I am multiplying it with 2, so 8, and here 2 2s are 4, 4 2s are 8. Okay, and now I add up all the positive numbers and subtract it with 8, and that sums to 4 again. Okay, so these are the different values for this polynomial with the values 0, 1 and 2. Okay, we go to the third polynomial now. P of x is equal to x cube. P of x is equal to x cube. In that, P of 0 is equal to 0 cube is equal to 0. P of 1 is equal to 1 cube is equal to 1. P of 2 is equal to 2 cube is equal to 8. Simple, right? Then the last sum, we can do it in the same format, or we can use an identity also. See, P of x, the polynomial it is given as x minus 1, x plus 1. When it is given as two such factors, we have to multiply it and make it as one polynomial. But instead, as we know this is a identity, I am writing it directly like this. Okay. A square, a plus b into a minus b is equal to a square minus b square. You are learning the identity in the next future exercise, or else you can multiply it also. And it adds up to be x square minus 1 square. And now when I substitute the values of 0, it becomes 0 minus 1 square. So minus, this square is for this alone. Okay. So 1 square and again minus. 1 square is 1 and minus 1. P of 1 is equal to 1 square minus 1 square. So this becomes 1 minus 1, so it becomes 0, and P of 2 is equal to 2 square minus 1 square. So 2 square is 2 2s are 4, 4 minus 1, 3. That's it. With that, the second sum also is over. We will go to the third sum now. Here, the third sum, actually you are getting into the exercise only in this third sum. Here what you are asked to do is, they have given you a 0 of a polynomial. What is meaning of 0 of a polynomial? The value of x, when we substitute that inside the polynomial, p of that value, particular value, whatever is given in the question, when you are substituting that value into the polynomial, if the polynomial's value becomes 0, that value of x is called as the 0 of the polynomial. It makes the polynomial to have a result of 0. That is the meaning of zeros of a polynomial. So, we'll do the first sum now. Okay. Third question, first sum in it. P of x is equal to 3x plus 1. And in that, I want to substitute x value as minus 1 by 3. So, I will mention it like this. P of minus 1 by 3 is equal to 3 into the place of x. I am going to substitute this value. 1 by 3 plus 1. So, what does the bracket mean? It's meaning multiplication. But when I have to specify a minus also with it, I use a bracket. Okay. This 3 and this 3 gets cancelled. And the remaining numbers are minus 1 plus 1. And the polynomial's value becomes 0. So, I can say minus 1 by 3 is the 0 of the polynomial. Minus 1 by 3 is the 0 of this particular polynomial, Okay. Now I think you have got it. What is the meaning of 0 of a polynomial? I should get a 0. When I substitute the value in the polynomial, I should end up with a 0. Then it is called as the 0 of a polynomial. Then going to the second sum. P of x is equal to 5x minus pi. And in that I want to substitute x value as 4 by 5. So I write it as P of 4 by 5. P of 4 by 5 is equal to, in the place of x I have to substitute 4 by 5. 4 by 5 minus pi. I can cancel these both the numbers. I get 4 minus pi. Are these both, does it end with a 0? It is not equal to 0. So 4 by 5 is not a 0 of this polynomial. Okay. 4 by 5 is not a 0 of the polynomial here. 1 by 3 is the 0 of the polynomial. Okay. I didn't write it down. We just write it down. Okay. 4 by 5 is not the 0 of the polynomial. The third sum. P of x is equal to x square minus 1. And in that they have given two values. Why? Again, the degree of the polynomials tells how many zeros this polynomial has got. Okay, see, this is a linear polynomial, so the x has got only one value. But here the degree of the polynomial is 2. X has got the power 2. So it means that there are two values of x in this polynomial. And so we are given two values, p of 1 and we have to find p of minus 1 next. Okay. 1 square minus 1. 1 square is 1 again. 1 minus 1 is 0. So yes, it is this value 1 is the 0 of a polynomial. And p of minus 1 is equal to minus 1 whole square. So the square is for this minus also. For that reason, 1 square minus 1 into minus 1 is plus 1. So plus 1 minus 1, it becomes 0. And so yes, minus 1 is also the 0 of the polynomial. I can write it as 1 comma minus 1 or the zeros of the polynomial. Okay. Then the fourth sum. P of x is equal to x plus 1, x minus 2. Okay. And they are given two values of x, minus 1 and 2. Okay. Here again, it's a simple way to tell you. It's, I don't know whether okay, I'll tell you. It's okay, no problem. See, already they have factorized the polynomial. They are given the factors only. If it has to be 0, then what does it mean? This term can be 0 or this term can be 0. X plus 1 can be a 0 or x minus 2 can be a 0. So what does it mean? X value, it becomes minus 1 here. X value, this 2 goes there, so it becomes 2 here. and asked whether minus 1 and 2 are the factors. Yes, minus 1 and 2 are the factors. But actually, this is the way, shortcut method for you to understand and prove. But the actual way would be, I have to multiply x plus 1 and x minus 2. We can use an identity if you are very thorough with an identity. But there may be people who don't understand an identity. So I am multiplying it also. Okay. X into x minus 2 plus first term with the whole bracket. The second term then plus 1. The plus 1 I have to put it as plus 1 and again the whole of the bracket. And it goes as x into x, x square, minus 2 into x, minus 2x. Then here 1 into x, 1x and 1 into minus 2, minus 2. Okay. And here both terms are x terms. So I have to add it up. X square and one is my negative number and a positive number. So minus 1x minus 2. X square minus 1x and minus 2. I have to substitute the values p of minus 1. So when I substitute minus 1 whole square, minus 1 into minus 1 and minus 2 again. This term becomes 1 and this term again minus 1 into minus 1 plus 1. So 1 plus 1 is 2. Minus 2 is equal to 0. Okay. And when I substitute the value of 2 here, p of 2 is equal to 2 square minus 2 into 2, sorry, minus 1 into 2, minus 1 into 2 and minus 2. So it sums up to be 2 2s are 4, minus 2, minus 2. So 4 minus 4 and so it also is equal to 0. I have proved it in the original way. But you can do also, if we are short of time, you can follow this method also. Okay. That method shows that you understood the sum, but this is the actual way to prove this sum. P of x is equal to x square and then they are given x is equal to 0. P of 0 is equal to 0 square. Obviously it will be 0. Okay. Then the next sum. P of x is equal to Lx plus m, and in that they want you to substitute in the place of x minus m by L. Okay. So in the place of x I am going to substitute minus m by L plus m here. So this L and this L gets cancelled. The remaining terms are minus m plus m and that is equal to 0 again. So yes, it is a factor. Then the next sum, P of x is equal to 3x square minus 1 and in that I have to substitute two values, P of minus 1 by square root of 3. When I substitute that value, 3 in the bracket minus 1 by square root of 3 whole square minus 1. So when I square it, this square root goes off when I square it. So it becomes 3 and again when I square it, this minus also goes off. Minus 1 into minus 1 is plus 1 and because of that it becomes 1 by 3 here. This 3 and this 3 gets cancelled and the remaining is 1 minus 1. Again it becomes 0. So 1 minus 1 by square root of 3 is a factor of this polynomial. Minus 1 by 3 is a 0 of this polynomial. Then the number other 0 is 2 by square root of 3. Again when I substitute it, 3 into 2 by square root of 3 whole square minus 1. Okay. So again 3 into 2 2s are 4 here and square root of 3 becomes, when I square it, it becomes 3 here. 3 and 3 gets cancelled but it is 4 minus 1, 3. And so this number 2 by 3 is not the 0 of this polynomial. P of x 2x plus 1 and x is equal to 1 by 2. So when I am going to substitute 1 by 2, 2 into 1 by 2 plus 1, 2 and 2 get cancelled. So 1 plus 1 is 2 and for that reason again it's not 0 of the polynomial. 1 by 2 is not the 0 of this given polynomial. Now they ask you to find the zeros of the polynomial in the each of the following. You have to find the zeros of the polynomial now. Okay, we have to find the zeros of the given polynomial. The last question they gave the zeros and they asked us to check whether they are the zeros of the polynomial. But here we have to find the zeros of the polynomial. And the first question is p of x is equal to x plus 5. Okay. Now I have to find the zero of the polynomial. So what I should do? I should have the x alone inside and bring the constant to the right hand side. And it turns out to be minus 5. To check, this is the answer. Okay. For you to check it as p of minus 5 is equal to, in the place of x I am going to use this value and it turns out to be 0. So this is the 0 of this given polynomial. The second question, p of x is equal to x minus 5. P of x, second question, is equal to x minus 5. It means x is equal to this minus 5. It goes to the right hand side as plus 5. So this plus 5 is the 0 of this given polynomial. Then the third question, p of x is equal to 2x plus 5. When this is given, again take the constant term to the right hand side. First step, take the constant to the right hand side. Then whatever is multiplied, coefficient of x, bring it to the denominator. As it is in multiplication, when it goes cross the equal to, it goes as a division, minus 5 by 2. So again minus 5 by 2 is the 0 of this polynomial. You can cross check it at any time. Substitute the value p of minus 5 by 2 is equal to 2 into minus 5 by 2 plus 5. 2 and 2 gets cancelled. Minus 5 plus 5 is equal to 0. This is the way how you cross check your answer. Then the fourth question, p of x is equal to 3x minus 2. And so I keep 3x alone here, take the minus to that side, it becomes plus 2. And remaining x alone I keep it here and take the 3 also the other side, 2 by 3. So 2 by 3 is the 0 of this polynomial. Then the fifth sum, p of x is equal to 3x. So you will think, what, there is no constant term, what am I to do? Simple. 3 of x, no constant term, it means it's 0. Okay. So x is equal to 0 by 3, that again it's equal to 0. Okay. Then the sixth sum, p of x is equal to ax, and the only condition they give, a is also again a variable, so the only condition they give is a should not be equal to 0. So ax is equal to 0, x is equal to 0 by a, and so it is 0. That's all. Okay, that's it. Then the last sum, seventh sum, p of x is equal to cx plus d, and the condition what they give, c should not be equal to 0 and c and d are real numbers. C and d are real numbers. Okay, let it be so. Then I consider cx plus d is equal to 0 first. Consider it is equal to 0. And I keep the x term alone here. Bring the d to the right hand side. It becomes minus d. And I keep x alone here, minus d by c. And so minus d by c becomes the root of 0 of this polynomial. I'll cross check it again. P of minus d by c is equal to c, and in the place of x I have to use this value minus d by c plus d. Okay, so c and c gets cancelled, minus d plus d, and so that also turns to be equal to 0. So I think now you will be knowing all the sums in your second exercise. With that, this exercise is over.